In this lesson we look at the angle between two lines. Let's look at a diagram firstly. A straight line there with gradient m1, a second straight line with gradient m2, and the angle between those two lines we'll call theta. Now this angle theta is found using the formula tan theta equals the absolute value of m1 minus m2 over 1 plus m1 times m2, where m1 and m2 are the gradients of the two straight lines. So that formula there, very important. Okay, you'll need to remember that off by heart. Let's look at some examples. The first one here, we need to find the acute angle between the lines y equals minus half x plus 6 and x minus 3y minus 15 equals 0. So that first equation, let's write that down, and we should be able to easily identify the gradient. Okay, the gradient is minus a half, so that's our value for m1. Our next equation, let's write this down, but we need to identify or get y by itself. So the minus 3y, let's bring that over, becomes plus 3y, and we'd have x minus 15, and to get y by itself we need to divide through by 3. So therefore we get y equals 1/3 x minus 5, and once we've got it in that form we can easily see that the second gradient is 1/3. So using our formula there, m1 minus m2, where m1 is minus a half and m2 is 1/3, let's write that down. It's all over 1 plus the product of the two gradients there. So 1 plus minus a half times 1/3. Now don't forget the absolute value lines. Now when we work all that out, we get minus 1. We've got to still take the absolute value of it, and the absolute value of minus 1 is in fact 1. So that's what tan theta is. So we've got tan theta equals 1. We take the inverse tan of 1, we therefore get that theta is 45 degrees. Terrific. Our second example, ABCD is a rhombus. Show that the diagonal AC bisects angle BCD. Okay, that's a result for a rhombus. Okay, a diagonal will bisect the angle. This actually allows us to prove that. So the diagonal AC, well, let's draw that in firstly. And we need to show that it bisects the angle BCD. So that angle there, we need to show that it bisects. And as a result, if we can find that angle, and hopefully they're going to be the same. Well, for angle BCA firstly, so that angle there shown, we're dealing with that line and that line. So the line BC and the line AC makes up the angle. So the gradient of BC firstly, and the gradient of AC secondly. Okay, gradient BC. Well, B and C are highlighted there. Now, do the gradient. We're using the y values firstly. So they're highlighted there. So we have 6 minus 4, and then the x values are 6 and 3. So we put it over 6 minus 3. And we do that little subtraction and division. We get 2 over 3. So our first gradient there is 2/3. The gradient AC. Well, if you look at the 2 points, A and C, they are our y values, so we have 6 and 1, so let's write 6 minus 1. Our x values are also 6 and 1, so we put them over 6 minus 1, and if we work that out, we get 5 over 5, which simplifies to be 1. Now, there's our tan theta formula, okay, to help us find the angle. Now, tan theta, this time, we're saying the theta, or the angle, is angle BCA, so we're going to write the tan of angle BCA equals, and we have m1 minus m2. Okay, there's our m1, and we'll use that as our m2. So we'll have 2/3 minus 1 all over 1 plus m1 times m2. There's m1, there's m2. So 1 plus 2/3 times 1. And we work that out. Take the absolute value, don't forget. We end up getting 1/5. So if you think about it, tan of the angle is 1/5. To find the angle, we need to take the inverse tan. So therefore, angle BCA equals the inverse tan of 1/5. And calculating that, put it in degrees rather than radians, calculating that we get 11 degrees 19 minutes. And that 11 degrees and 19 minutes, let's mark that in on the diagram there. Now let's move on to angle DCA. So for angle DCA, we're using that line there, which is CD, and the other line, which is AC. So let's consider the gradient of CD and then the gradient of AC. The gradient of CD firstly. So we're interested in the 2 points C and D highlighted. Our y values firstly, so we have 6 minus 3 over our x values, 6 minus 4. We work that out, works out to be 3 over 2. Now the gradient of AC, well, we already found that earlier, was simply 1. So tan theta, where theta is angle DCA, so let's write tan of angle DCA equals the M1 minus M2, where there's M1 and there's M2, so we'll have 3 on 2 minus 1, all over 1 plus M1, M2, so M1 is 3 over 2, M2 is 1, so it's 1 plus 3 over 2 times 1. Again, working that out, but taking the absolute value, we get 1/5. So if tan of angle DCA equals 1/5, we take the inverse tan of 1/5, and we end up again getting 11 degrees 19 minutes. So same angle as before, let's mark that in on the diagram. So looking at them, they are the same angle, terrific. So therefore we can say that angle BCA equals angle DCA, and as a result, therefore the diagonal AC bisects angle BCD. Excellent. Well, that concludes the lesson. Good luck with your questions.